So this last video, you're going to basically do the opposite of what you've been doing in the previous videos. In the previous videos, you're going from the formula to the name. In this video, you're going to go to learn how to take the name of a compound and write the formula for it. This tends to be a little tricky at first. So if you find yourself struggling a little bit, stick with it, keep practicing, and they get better as you go. But you need to practice these to get really good at them. And you do have to take into account the oxidation number. So this really is like the culmination of everything you've learned in chapter 7 so far. So in order to write out the formulas, you have to balance the charges. Remember, the sum of the oxidation numbers has to add up to 0. That's still true. So examples, sodium chloride. In order to write this out, the first thing you do, that I like to do anyways, is I like to say, okay, sodium is, write out the formula. Sodium is Na. Chlorine is Cl. Now the next thing I like to do is I like to look up the oxidation numbers. So look up sodium on your sheet. It's a +1 charge. Remember, chlorine is usually a -1 charge. Or if you go on the back of your, well, depending on what you consider the back of the yellow sheet, if you go where the IDE endings are given to you, it says chloride is a -1 charge. Actually, scratch that, chloride isn't on there. But chloride is a -1 charge. Remember, chlorine is usually a -1 charge if you look on the rules. So somewhere we're going to find out where it's -1. Anyways, if I look at these, does a +1 and a -1 equal 0? Do they cancel out? And the answer is yes. So in that case, I am fine with a 1-to-1 ratio. One of these cancels out one of these, so I leave it as a 1-to-1 ratio. I don't actually write the ones in there, but that's my formula. That's it. It's NaCl. That's why we write it as NaCl, because the charges balance like that. Lithium nitride. First thing I'm going to do is write out Li for lithium. Nitride is nitrogen. Now if I look on my yellow sheet, lithium is a +1 charge. Nitride, now this one where you have the IDE endings, is there. Nitride is nitrogen with a +3 charge. Now you got to ask yourself, that should be a -3. Let's rewrite that, -3. Nitride is -3. Does a +1 and a -3 equal 0? The answer to this one is no. So how do you make this cancel? Do you need more negatives or do you need more positives? The answer is you need more positives. Well, how many +1s do you need to cancel this out? The answer is 3. You need 3 +1s to cancel the -3, and now it will equal 0. But when I put this 3 here, that means I need 3 lithiums to cancel out this one nitrogen. So I put a 3 in the formula here. 3 lithiums balances out the 1 nitrogen. And if you want to double check, lithium has a +1, nitrogen has a -3. 3 +1s balances out the -3 charge. The last one, calcium phosphate. Calcium is, I'm going to write it over here, Ca. Phosphate is PO4. So that's my formulas. Now I got to figure out, do I need to add numbers here and here? If the charge is balanced, then no. If they don't balance, then I'm going to have to add a little bit more to this. So in this case, calcium is a +2 and phosphate is a -3. Does that equal 0? No, that does not equal 0. And the tricky part about this one is I can't get a 2 to go into a 3. What I can do though, is I can get, they both go into 6. So in order to make this a +6, I need to multiply it by 3. In order to get this to a -6, I need to multiply it by 2. So what this means is I need 3 calciums and 2 phosphates. So I'll put a 3 here. Now I can't just put a 2 there and leave it like that. In order to have 2 phosphates, because this is a polyatomic, I need to put it in parentheses. Let's rewrite that because that was terrible. Ca3, PO4, parenthesis 2. So that's where I get my 3 calciums and my 2 phosphates. So that's how you balance the charges as you go from the name to the formula. So step 1 is write out the formulas of each individual component. Step 2 is figure out their charges. Step 3 is figure out how to get them to balance. And then step 4 is write those numbers in the formula to actually balance it. Now, transition metals can have several oxidation states. So they will be indicated with a Roman numeral to tell you what the charge of the metal is. And again, remember, just a reminder from last video, the value of the Roman numeral is equal to the charge of the metal. So if you see a Roman numeral, that actually makes your job easier, not harder, in my opinion. Because the Roman numeral tells you what the charge of the metal is, you don't even have to look it up. It saves you the time of looking it up on your yellow sheet. So an example would be tin 4 sulfide. So what I do is, as normal, write the formula. Tin is Sn, sulfide is sulfur, so SNS. Now, normally you'd have to go on your yellow sheet and look up the charge of tin, but you don't because this Roman numeral tells me that the charge of tin is a +4. So this 4 tells me that it's a +4 charge. Sulfide is sulfur with a -2 charge. Again, use those IDE ending hints on your yellow sheet to help you figure out these charges. Because if you look at sulfur, it has multiple options on your yellow sheet, but sulfide is always a -2. Okay, now does a +4 and a -2 balance? The answer is no, it doesn't, or it doesn't equal 0. So to get it to equal 0, I need 2 of these -2's, because 2 2's go into 4. So I multiply this by 2. 2 times -2 equals a -4. That -4 will cancel out this +4 to equal 0. So what I need is 2 of these, which would go right there. So this would be SnS2. So fundamentally, this problem is no different than the previous slide. The only difference is that you got Roman numerals to work with and how to deal with those. So let's try 2 more examples here, or a couple more. I believe there's only 2. Example number 1 is iron 2 chlorate. So iron is Fe. Chlorate is ClO3. Now if you look up chlorate on the polyatomic part of your yellow sheet, it has a -1 charge. Now iron, if you look it up on your yellow sheet, it's a +2 or +3, but you don't even need to do that because it tells you that it's a +2. That's what this Roman numeral means. It means that this is a +2 charge. Now, this does not balance. I need 2 of these. I need to double my -1. 2 -1s will balance out a +2. Now, in order to get 2 of these, I need to put it in parentheses. If you have more than one polyatomic, you put it in parentheses. So I put a 2 there. And that's it. Now, iron 3 chlorate. Very similar. We've got FeClO3. Chlorate's still a -1, but the iron in this case is a +3 charge. Now, in order to balance out this +3, I need 3 of these this time. And now that I have 3, same thing, parentheses, and I put a 3 right there. So that's the difference between iron 2 chlorate and iron 3 chlorate. Remember, Roman numeral gives me this charge. It tells me this. So don't overthink those types of problems, and good luck balancing.